Good afternoon, everyone. Thank you for joining us. I hope you've had a great week so far. I'm looking forward to spending the time with you. So today's session will focus on mostly 8th graders to 12th graders, and also if you're in college and you are taking pre-algebra all the way to pre-calculus, we have some content that will be helpful to you as well. Feel free to ask as many questions as you have during the session. I would not have a problem adjusting what I'm trying to do to make sure that your needs are met. So we'll just wait for a few more moments and wait for some more students to come through, and then we'll get started. While you're waiting, if you have not subscribed to our channel, please go ahead and subscribe to the channel so that when we have events happening on our channel, you get a notification. So let's enjoy our time together, and I hope you will enjoy the time as well. Good. For those who are new, welcome. I can see some new faces. Welcome, welcome, welcome. Esther, good afternoon. And Takunda, Bondway, good afternoon. Ini, good afternoon. All right, we'll wait for like maybe 30 seconds or just a little bit after, a little bit more, and then we'll get started with our questions today. So I'm going to be walking through questions on grade 8 math, algebra 1, algebra 2, and geometry. So those are going to be the main those are going to be the focus areas for what we will do during our session today. And while we wait, just want to let you know that over this summer we'll be having some sessions as well to help you. We'll be looking at some group sessions. So if you have some need to either brush up what you have learned, or to prevent knowledge loss, we'll offer this opportunity to you. So if you have any questions about that, feel free to reach out to us. I'll kind of say this again towards the end, just so that others are aware of it as well. All right, so we'll get started. What I've tried to do today is some of the topics from the last week. I wanted to bring them back to the forefront and address them again, just so that if you're in those grades, you'll have an opportunity to ask more questions or see different examples of those topics that we walked through at that time. All right. So let's get started. So we're looking at the local grocery store sells 8 pounds of apples for $6, and we want to find out the unit rate, and then we want to find out how to apply that to answer a different question. So what is the unit cost per pound of apple? And if the customer bought 17 pounds of apples, how much will she spend at the grocery store? How much will she spend at the grocery store if she bought 17 pounds of apples? Always remember, you can ask as many questions as you want as we're walking through these problems. Feel free to reach out, ask the questions that you have on your mind. If the approach is maybe not as clear to you as you want it to be, also reach out, and then I will be glad to go back and walk through some other examples with you. All right, Jaden, looks like you're having an early start. Good stuff. All right, let's see if our 8th graders are going to give us some answers. Otherwise, I'll show you what to do here, and so that we can address as many questions as possible today. All right, let's go ahead and start. So I see 40. Oh, Manuel, good afternoon. Welcome aboard. Thanks for joining. Okay, let's go ahead and start. So I see $14 somewhere. So let's see which answer is correct. So we're looking at the unit cost. So unit cost is really asking you to find out the cost of one unit of the item. And here we need to focus on our unit. So we're looking at 8 pounds for $6. So our unit here is going to be pounds right here. So we need to find out the cost per unit pound of apple. So if we have 8 pounds for $6, we want to find out the cost of 1 pound. So there's a simple trick I use here. We're looking for 1 pound. So what I'm going to do here is we can say 8 over 1 is equal to 6 over x. And we can get the value of x. That will give us the unit rate of apples in this grocery store. So you have different ways to approach this. The one that I think most students like to use is the cross product, and some may call it cross multiplying. So that's an approach we will use here. So I'm going to cross multiply over here and cross multiply here. So that's going to give me 8 multiplied by x is equal to 6 multiplied by 1. And so we're going to divide both sides by 8 to get the unit rate for x. We want to get the value of 1x. So this is going to give you x is equal to 6 over 8. And you can divide and simplify. So you can divide this by 2. This is going to give you 3 over 4. And now, so you have x is equal to 3 over $4, right? So we're just going to divide that and find out what that actually translates to. So 3 divided by 4. How many groups of 4 in 3? We have 0, put a period here, a decimal point. So we introduce a 0 here. 30 divided by 4. We have 7. 7 multiplied by 4, we have 28. We subtract, we have 2 here, and then we bring down another 0. 20 divided by 4, we have 5. 5 multiplied by 4, we have 20. So we subtract and we have 0. So therefore, 1 pound is going to be 75 cents, or you can write it as $0.75. So now the question is, if the customer bought 17 pounds of apples, how much would she pay at the grocery store? So all we're going to do is now multiply 75 cents by 17, so we have 1 pound is equal to $0.75. We need to find out 17 pounds. This is equal to, let's make this y. So this is now going to give us 1 over 17 is equal to 0.75 over y. Now we're going to do our cross product again. I think most students like that the most. So we're going to go ahead and we have 1 multiplied by y is equal to 17 multiplied by 0.75. So we're going to go ahead and multiply 17 and 0.75. So 17 and then 0.75. Now we're going to go ahead and multiply this. We're going to try to do it on our own first, and then we can use it. You can use a calculator to double check your answer. So 7 multiplied by 5, we have 35. So we're going to write 5 here and bring a 3 up here. 1 multiplied by 5, we have 5 plus 3, we have 8. And then we go over to the 7 on the bottom row, and so that's going to allow us to add a 0 here. 7 multiplied by 7, we have 49. We're going to write 9, and then we're going to have 4 here. 1 multiplied by 7, we have 7 plus 4, we have 11. And then this is 0, so there's no point dealing with it. And I'm going to replace all this with zeros so we can add together. So 5 plus 0, we have 5. 8 plus 9, we have 17. So we write 7, bring 1 up here. 1 plus 0 plus 1, we have 2. 1 plus 0, we have 1. So now we're not done. We need to make sure we understand how many decimal digits we have. We have 2 here and we have 0 here. Add them together, we have 2 decimal digits. So we're going to move our decimal 1, 2. So that's going to be our answer. So this is going to give us $12.75. So in this store, if this customer bought 17 pounds of apples, you should expect the customer to spend $12.75 on apples. All right, Manuel, good job. Good job. Everyone, thanks for trying. I like the fact that you're participating. I enjoy that. Thank you for your participation. Are there any questions on this topic so far? All right, let's go to the next one. Okay, this topic we had it last week. I wanted to make sure we can clarify any questions that you may have about this type of question. We're looking to write this equation of this function in the vertex form. We're going to write this in vertex form. So we'll start off by making sure you remember that vertex form means you have f of x is equal to ax minus h squared plus k, where the point hk is your vertex. So also remember, what is your vertex? Your vertex is going to be that point on the quadratic graph where you are changing direction. So usually you can have a maximum or a minimum. A maximum is when you're going all the way up and then you start to go down. A minimum is when you're going all the way down and you start to go up. So you're just changing direction. So that point where you start changing direction is your vertex. So the way I showed it to you last week, I'm going to use that same method today, and I hope that would make sense, make it even more clearer to you. So we're going to look at our vertex. So our vertex, remember I said, is the point on the graph where you start to change direction. So if I look at this graph, I am going up, and when I say going up, I'm focused on the y-axis. So if you look at the y value continues to increase, and then it gets to a point, and then it starts to decrease. So that point here is what we're going to consider. That is our vertex. And your vertex is going to be written in the form hk. So your h represents your x value, and then your k represents your y value. So what's our x value here? So this point here is going to be the point 3, 5. So this is the point 3, 5. So therefore, we're going to go ahead and replace h and k in the standard function with 3, 5. So this is going to give us f of x is equal to, we don't know what a is, I'm going to show you how to get to a. So a, and then x minus, what is our h? H is 3, and then squared plus our y value is 5. So this is the framework that we're going to work with to arrive at the value of a. So now you may be wondering, how do I get a? You may sometimes this is the confusing part of this vertex form of quadratic function. So the next thing you're going to do is you're going to pick any point. I would recommend you don't use the vertex in this case. Just pick any other point on the graph. I'm going to look at 2, 3. Let's look at this point right here. It's a perfect point. So I'm going to use point 2, 3. All right. So what does this mean? It means that if x is equal to 2, then f of x must be equal to 3. That's what this actually means. So now I'm going to we're going to make we're going to write a mathematical statement, which means that f of 2 is equal to 3. So now that we have this function, this mathematical statement, we're going to try to substitute that into the function that we created earlier. Now, how do we do that? So it's going to give us f of 2 is going to be a, and then we put this parenthesis here, 2 minus 3 squared plus 5. So what is f of 2? This is going to be 3. 3 is equal to, what is, we don't know what a is, so let's go ahead and do this. 2 minus 3 is -1. We square that, and then we add 5. So therefore, we see that 3 is equal to -1 squared is going to give you 1. So this is going to give you a plus 5. Now we subtract 5 from both sides, and we have -2 is equal to a. So now our function is going to look like this. This is what the function becomes. We have f of x is equal to -2. We have x minus 3 squared plus 5. So how can we tell that we're right? Just the fact that we have a negative value tells us that we're headed in the right direction, because our graph is going up and coming down. So it's pointing upwards, so that means that you have a maximum. Anytime you have a maximum, your a is negative. So that's one way to check. If our a was positive, I would expect the graph to look like that. But when it's negative, it has to look like that. Okay, are there any questions? Any questions on this? Does this make sense? Actually, I have another example towards the end of the session, because I want to make sure this is an important topic to understand, because you're going to deal with it again in Algebra 2. So if you're introduced to it in Algebra 1, I want to make sure you have a good grasp of how to approach it. All right, if there are no questions, we'll go ahead to the next question. All right, let's go to the next question. And if you have questions about this, go ahead and send the questions across, and we'll have another chance to work on a problem like this towards the end. And if we have some more time after that, we'll be able to look at another example together. Okay, so for geometry students, we have a spherical container with a circumference of 24 pi inches. And that container is filled with water using a cylindrical cup with a diameter of 6 inches and a height of 8 inches. How many cups of water will be required to fill the spherical container? So we're looking at a spherical container that has a circumference of 24 pi, and that the unit of measurement is inches, and we're filling that with water using a cylindrical cup with a diameter of 6 inches and a height of 8 inches. How many cups of water will be required to fill the spherical container? I'm going to give you some time to think through this. I want you to be able to, this is applied geometry. So you're applying what you know about volume, and you can see here we have a sphere and we have a cylinder. So we're going to apply the knowledge of volumes, and I want you to be able to think through problems that may not be as straightforward. I know in most of our schools, they would give you the formula. So let me go ahead and give you the formula. But I want you to always remember volume. Volume is area multiplied by depth, or area multiplied by height. That's all it is. So whatever shape you have, whatever three-dimensional shape you have to find the area of the base of that shape and then multiply it by the height. The sphere is a little bit different, and I don't think we have enough time to walk through why the sphere is different. But your volume of a sphere is going to be 4/3 pi r cubed, and then the volume of a cylinder is going to be pi r squared, which is the area of the base, because a cylinder looks like that. And then, so you can say that the base is circular, and then you multiply that by the height of the cylinder. So this is your r here, this is your h. So volume of your cylinder and volume of your sphere. So that should give you something to work with as you start solving this question. Okay, so let's go ahead. I'm going to wait for a few more moments, and we'll go ahead and solve this one together. It's actually not difficult. It's just, you just have to think a bit. You have to think broadly to understand what's happening. Let's see if we can come up with us. We can't really draw a sphere because it's three-dimensional. I don't think I have anything here to draw it easily. Okay, so we have a sphere. So the volume of our, let's go ahead and find the volume of our sphere. So the volume of a sphere, and what I want you to do is, I don't want you to find out what pi is. I don't want you to multiply by 3.14 or 3.1. Just leave it as pi and work with it and see, and you'll see how that actually allows you to work better with some of this type of questions than just going ahead and multiplying. I think most times it's a time waster. So let's go ahead and find the volume of the sphere. Here we have the circumference of the sphere. That may throw it may throw you in a loop because you're not probably sure what the circumference of a sphere is. The circumference is the same as 2 pi r. 2 pi r. So we have 24 pi is equal to 2 pi r. Now we want to find the radius. So we're going to divide both sides by 2 pi because we want to isolate the radius. So now we have the radius, and here, good practice is pi is going to cross out pi. 2 divided by 2, 1. 24 divided by 2, we have 12. So now our radius is going to be 12. So now the volume of this sphere, the volume is going to be 4 over 3 multiplied by pi multiplied by 12 cubed. And so now we can go ahead and cross this out, and we have 4. So I'm going to write it this way. Volume is 4 pi multiplied by 4 multiplied by 12 multiplied by 12. And I'm going to do it this way because I don't want to use a calculator in this. If you have your if your teacher allows you to use a calculator in your test, go ahead and use it. But I'm going to show you how to do the math so that when you see your when you get your answer in the calculator, you can double check your work. So now the volume of a cylinder is pi r squared h. Here we have a diameter of the cylinder. So diameter is equal to 6. We also know that diameter is equal to 2 multiplied by radius. Okay, diameter is 2 multiplied by radius, so 6 is equal to 2r, and so we divide both of sides by 2 to get radius is equal to 3. So now what's the volume of our cylinder? We have our height equal to 8. So the volume here, I'm going to call this V1 here and call this V2. So V2 here is going to be pi multiplied by 3 squared multiplied by 8. So this is going to give me pi multiplied by 9 multiplied by 8. And so now we want to find out, here's what we have. We have a spherical container, and we know the volume of that spherical container. It's 4 pi multiplied by 4 multiplied by 12 multiplied by 12 for the sake of this discussion. And then we have a small cup, and we want to find out the volume of that cup because that cup is going to be the one you use to fill up the bigger object. So you want to find out how many of those cups are going to be required to fill up that large spherical container. So all we're looking for is the volume of the sphere, the volume of the cylinder, and we're going to divide to find out how many instances of the small cup are going to be required to catch up with the volume of the large spherical container. So this is what I'm going to do here. So I'm going to say number of cups is equal to V1 divided by V2. So we're going to use that to find out the value of the number of cups. Okay, so now we're going to look at our V1. Let me create some more room here. So our V1 is 4 pi multiplied by 4 multiplied by 12 multiplied by 12, and our V2 is pi multiplied by 9 multiplied by 8. So now we're going to go ahead and cross things off. You can see here that pi is going to cross off. Let's divide 8 by 4. We have 2, and then we can cross this out. We have 1. We can divide 9 by 3. We get 3. We divide 12 by 3. We get 4. And then we can divide 3 by 3, 1. And then by 4, we have, by 12, we have 4. And then we can now divide 2 by 2, and 4 by 2, we have 2. So this is going to be number of cups. You can see that we just have 4 multiplied by 2 multiplied by 4. This is going to give you 8 multiplied by 4, which is equal to 32. So in other words, what this is trying to tell us, is trying to indicate is that in this situation, you're going to need 32 of such cylindrical cups to fill up that spherical container. Are there any questions? Are there any questions? Does this make sense? All right. Let's go to the next topic. Next question. So here we're looking at some Algebra 1 questions. We're looking at quadratic equations, and we're going to focus on word problems. So we have the area of a rectangle is 180 square inches. The length is 3 inches longer than the width. Find the dimensions of the rectangle. Thank you for your response, Esther. It helps to know that when I get a response, it helps to know that you're either following, or it lets me know whether I lost you, so I can go back and review a few things to make sure that you have an understanding. So we have the area of a rectangle is 180 square inches. The length is 3 inches longer than the width. Find the dimensions of the rectangle. Let's give you a few seconds. Let's see if you can get this in a minute. If you're not sure what to do with this, let me know. I'll go ahead and show you what to do. But the first thing I like to do whenever I have this type of word problems is to draw the object that is in question. So we have 180 is going to be here, and then we need to find out the dimensions. So let me know if you have an answer, and then we can look at them together. Okay, so let's go ahead and attempt this together. So we have the rectangle here. We know that the width, let's use a variable. So let's say that the width is equal to x, and then we're told that the length is 3 inches longer than the width, so it's going to be x plus 3. Now we want to find out the area of the rectangle. So area of a rectangle is equal to length multiplied by width, which is going to be, the length is x plus 3, and then our width is x. So we can just go ahead and say this is x multiplied by x plus 3, and this is going to be 180. So we're going to go ahead and distribute. Remember PEMDAS, we'll distribute first. So 180 is equal to x squared plus 3x. And so we can see that we have something that looks like a quadratic equation here. So we're going to write it in the standard quadratic equation format. And that is going to be ax squared plus bx plus c equal to 0. And to do that, we're just going to subtract 180 from both sides. So we now have x squared plus 3x minus 180 is equal to 0. Now we're going to factor this quadratic equation. You can use any method you like. You can use factoring, you can use completing the square, you can use quadratic formula. Anything that you're familiar with would work. Let's see, which method should I use here? Let's go ahead and use the quadratic formula. Where is the other 4? Can you shed some more light on your question? Where is the other 4? All right. I don't think I understand your question. I think it's Abijah. I don't think I understood the question. Can you restate it, and then I'll be able to respond and help you out. Okay, so Esther, you have it. So let's go ahead and use the quadratic formula. And looks like Esther has used the factoring method, which is fine. Any method you use is fine. It doesn't really make that much of a difference. So we're going to have our quadratic formula is written this way: x equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. So we're going to compare with our standard quadratic equation here. So we can see here that a is equal to 1, b equal to 3, and c equal to negative 180. Now we're going to substitute these values into the equation, the quadratic formula. And so that's going to give us x is equal to negative 3 plus or minus the square root of 3 squared minus 4. A is 1, and then c is negative 180. And then we're going to divide that by 2 multiplied by 1. So this is going to be negative 3 plus or minus the square root of 9, and then negative 4 multiplied by 1, that's negative 4, multiplied by negative 180. Remember, negative multiplied by negative is always positive. So this is going to be plus 720 divided by 2. So now we have negative 3 plus or minus the square root of 729 divided by 2. And we're going to end up with the square root of 729. If you put that in your calculator, you should get 27. So it's negative 3 plus or minus 27 over 2. Okay, so let's get some more room. Okay, so this means that we have two different answers. We have negative 3 plus 27 over 2, and we also have negative 3 minus 27 over 2. So now we're going to simplify this. So x is equal to this, x equal to this here as well. So this is going to be x equal to 24 divided by 2, and x equal to 12. Here we have x equal to negative 30 divided by 2, x equal to negative 15. Now we have to make a very wise choice here. Remember that we're dealing with lengths, and lengths can never be negative. So because lengths can never be negative, what am I going to do? I'm going to discard this option. And then we're going to work with x equal to 12. So we know that our width is x, and then our length, we said earlier, our length is x plus 3. So here our width is going to be 12. Our width is 12, and then our length is going to be 12 plus 3, which is equal to 15. So therefore, the dimensions of our rectangle, dimensions are length equal to 15. Length is 15 inches, and then width equal to 12 inches. So that's all. This is applying what you know about quadratic equations to solving what problems? Okay, I can go, Abiji, I can take a look at that. I can take a look at that in a few minutes. So does this make sense to everyone? Is this clear? So you have a question from the previous one. So if anyone has any questions, I'll come back to you. I just want to check the other question that was raised. Okay, where did you get the other 4 from? So let me highlight the 4s. We have a 4 here, we have a 2 here, and then we have a 4 here. Those are the 4s. So these are the 4s. When we do all our division, this is how we get to these different 4s. So I think your question makes more sense now. Okay, so just so you remember, this is the volume of the larger object. This is the volume of the smaller object. All we're doing here is we're dividing V1 by V2. And I just do a lot of cancellations, and that's how I get to this value. Something else you could do is you can also say 4 pi multiplied by 4 pi. Sorry, 4 pi multiplied by 4, you have 16 pi. And then 12 multiplied by 12, we have 144. And then you can divide it by pi multiplied by 72. Okay? Pi multiplied by 72. And then you can divide 72 by 72, 1. 144 divided by 72, we have 2. And then pi crosses out. So you now have 16 multiplied by 2, which is 32. So there are a lot of different ways. I just want you to see that there are lots of different ways to go about it. I just like to use this method. It shows you how to break things down instead of having to depend on your calculator to solve the problem. I hope this clears it up for you. All right. So Algebra 2 students, if you're in geometry, going to Algebra 2, this is something you should be prepared to deal with. You should also feel comfortable dealing with. There's really not much to it. This is about solving fractions, but I'm not going to solve the fraction here. I'm going to show you a different method. What I'm going to do here is I'm going to find out the greatest common factor of all these denominators. So we're going to find the greatest common factor of all the denominators. So I have x squared, I have x squared. So you can see that x is a factor of x squared. So we can see, based on that alone, we can use x squared as our least common denominator. We're using the least common denominator. So we find x squared is going to be our least common denominator. And what we're going to do, so LCD is equal to x squared. Now we're going to multiply every single term in this equation by x squared. So let me show you what that looks like. So I'm going to have 1 over x squared. I'm going to multiply that by x squared. You can see that this crosses it out. So that's going to give me 1. 4 over x. I'm going to multiply that by x squared. So the x here crosses out the power here. This is going to give me 4x. And then we have 3 over x squared. I'm going to multiply that by x squared as well. and then we can see that this crosses out. I have 3. So now that we have all of this, instead of having this fraction, we're going to just use algebraic terms. So instead of 1 over x squared, I'm going to replace that with 1. 4 over x becomes 4x, and 3 over x squared becomes 3. So now we can solve a simple linear equation. So we're going to subtract 1 from both sides, and we have 4x is equal to 2, and we divide both sides by 4, and then x is equal to, we can cross this out, we have 1, 2, so x is equal to 1/2. So that's all you do. So let me just run through it again. The first thing you want to do is find the least common denominator. Find the least common denominator for all your denominators, and then you multiply every single term in your equation by the least common denominator. The reason why you do that is you get rid of the denominators, and now you create a linear equation that is very simple to solve. All right, that's that. Let me know if you have any questions. As we go through, if you have any questions on any topic, let me know. I will be very happy to go back and look at it with you. Okay, let's go ahead to the next question. So we're looking at Pythagoras theorem here. So here, Shane lives 10 miles from school if he travels across the diagonal path. The other path requires him to walk 5 miles east. So I want you to actually try this. 5 miles east to the park and north 8 miles to his school. So he's going to go to the park first, and then he's going to travel 5 miles east to the park, and then with an unknown number of miles to his school from the park. So what you're going to do here is, this information should allow you come up with a right triangle and use the Pythagoras theorem to find out the distance between the park and his school. We're going to use Pythagoras theorem here. I like to always start this by identifying his starting point. So the starting point here is, let's call this home. Okay, so we already know that. We're saying there's a diagonal path. So let's say this is the path to school. Okay, actually that's not a good diagram. It's too steep. It's not steep enough rather. So we're going to go this way. All right, and then this is home. 75 squared. You're on the right path, but I want you to take a look at it again. You're very close. 75 is something that we need in the answer, but there's just an error in the way that you've gone about it. Okay, looks like Ayo has an answer. That's good. And okay, so looks like we got a few answers. So let's go ahead and try to attempt this together. So we have home here, and then this is our school right here. This is our school. And we're going to travel 5 miles to the park. So this is our park right here. And from the park, we're going to our school. So if this is straight, this will be a right triangle right here. And then our lengths are, we have 10 miles here. I'm just going to ignore the miles. And then here we have 5, because we're going from the home to the park, we're going east. So if you look at your compass, this is your center. Going up is north, going right is east, left is west, and then downward is south. All right, so now we have an unknown value. We're told that this is x. We're going to look at our Pythagoras theorem. Pythagoras theorem tells us that the square of the sum of the shorter legs is the same as the sum of the squares of the shorter length is the same as the square of the hypotenuse, which is your longest length. So we have a squared plus b squared equal to c squared. and that's what we're mostly used to seeing. So in this case, our a squared is going to be 5 squared plus b squared is going to be x squared equal to 10 squared. So now we have, you can simplify this and make this 25 plus x squared equal to 100, and then you can now subtract 25 from both sides, and so x squared is equal to 75. And okay, Esther, looks like you're on the right path. Now we find the square root of both of these sides, and we have x is equal to, I'm going to just write 75 as 25 multiplied by 3. So I'm going to write it this way, 25 multiplied by 3. This is going to give me 5 square root of 3. And 5 square root of 3 is about 1.73. So I think you guys are right. All right, good job. So x is equal to 8.7 miles. Don't forget your units whenever you're doing math, whenever you're solving mathematical problems. Don't forget your units. Some teachers may actually prevent you from getting the most points. They would actually take some points away if you don't have units. So just make it a habit to always write your units. All right. Looks like we're good with this. I think everyone has done well. Everyone has done well with this question. And so we have a final answer before our puzzles. So I said earlier that I have 2 questions of this type, trying to find the equation of this function. Let me write it this way and I'll tell you what values I'm looking for. Let's say f of x is equal to a, and then we have x minus h squared plus k. So I want you to tell me the values of a, h, and k. How about we do that? So go ahead, give it a try. Find the values of a, h, and k. We need to find the values of a, h, and k. Go ahead, if you can, go ahead and give me h and k first so I can see if you're on the right path. So let's get the values of h and k. Remember that hk, so let's take note of that. That's important to note. Hk is going to be the coordinate of the vertex. That's going to be the coordinate of the vertex of your quadratic function, of your graph. And we said earlier, like I said earlier, the vertex is the point on the quadratic function where the function changes direction. So you can see in this function here, we're starting off at the positive y, and we go all the way down to about -3. Then at -3, we go all the way up on the y. So you can see that this is this is going to be our vertex. It's the point of the direction change. Okay, so I see 2, -3. Okay, that's good. So our vertex is going to be at 2, -3. So that is this point here. So our vertex, let's do it here. Vertex is going to be 2, -3. Remember I said earlier that h is going to be your x coordinate and k is going to be your y coordinate. So at this point, x is equal to 2, y equal to -3. So now our function, the next step after this, our function is going to be x minus our h is here and this is our k. So x minus 2 squared plus k is -3. So instead of saying, well, this is what it looks like, but you can always do that ahead and just say -3. But for the sake of this, I'm going to go ahead and do it this way. ax minus 2 squared minus 3. Okay. Esther, you forgot your exponent on your x minus 2. And think about it, if I had 0 as the distributing factor there, that would make everything 0. So I would just have a straight line with at minus 3. So let's think about it a bit more. So now what we're going to do is we're going to pick a random point that is not the vertex. I want you to always remember that, because if you use the vertex, you're going to get zeros. And I'm sure that's why Esther probably got 0. So we're going to use any point that is not the vertex. I like to use points that are very easy to identify. So I'm going to just use here, I'm going to use this point right here. Okay, our point that we're chosen here is going to be, our point is 1, 0. You could also use 3, 0 if you want. So I'm going to use 1, 0. It's going to be easy to work with. And what this means to us is that f of 1 is equal to 0. So now let's go ahead and plug that into the function that we created. So the function we created was f of x equal to a multiplied by x minus 2 squared minus 3. So f of 1 is going to be a multiplied by 1 minus 2 squared minus 3. So now that we know that f of 1 is 0, we'll go ahead and say here 0 is equal to a multiplied by negative 1 squared minus 3. So this is going to give us a minus 3 is equal to 0. And so we go ahead and add 3 to both sides. And so we have 3 is equal to a. So what that tells us our function is going to look like is something like this. F of x equal to 3. Remember, all I'm doing is I'm replacing a with 3. 3x minus 2 squared minus 3. So 3x minus 2 squared minus 3. How can we check if we're even right? The fact that a is positive tells me that we've done it right. And I mean, there could be computation errors. You could be making some errors with the way you add and subtract and all of that. But just know that if your a is positive, it should be facing upwards. If your a is negative, it should face downwards. So those are the important points to note. Are there any questions? How do we get x? Well, remember that it's a quadratic function, so you're going to have x in your function anyway. So what I did here was, after getting the function using the vertex h and k, you plug that in here. I picked a point, any random point on the graph. I just like to use the simple points. So I use 1, 0, because x is 1, y is 0. So 1, 0 is the point. And remember, what does this mean? It means that f of 1 is equal to 0. F of 1 is equal to 0. So 1 is your input and 0 is your output. So that means that if you have 1 as your input into this function, you should get 0 as your output. So we're using that to work through the rest of them, and we use that to get the value of a. So we don't really need to find the value of x, because x is an important part of the function. If you have questions about this, do let me know, and then we can, as we plan out our summer, I can also add this as a topic to go into more detail with. All right, so let's go ahead and have our puzzles. We have 2 of them as usual. I'm going to try to run through them as quickly as possible. So 9 equal to 18, 8 equal to 24, 7 equal to 28. What is 6 going to be equal to? Fantastic. Fantastic. Good. Jaden, good job. Good job. Esther, Good job. Okay, we have two answers. Usually I like to have 2 or 3 answers and then we'll go ahead and explain it. So our puzzle here is going to be 9 multiplied by 2, 8 multiplied by 3, 7 multiplied by 4. So you can see that the multiplier is the multiplier is increasing by 1 as the number to the left is decreasing by 1. So therefore we have 6 multiplied by 5, and that's going to give us 30. So that is 30. Great work, Abijah, Manuel, Ayo. Good work, good work. So we have one more. Let's do one more puzzle before we call it a day. So what is the missing number here? What is our missing number here? Thank you to our Facebook participants. Always appreciate it. Okay, let's see if we have an answer. 5. Wow, that's good. 5. All right. Everyone is 4. Okay. 5, 4, 5, 10. All right. Everyone is doing well so far. Okay, so let's give this a shot. So I'm going to add right here. So add so we have 2 plus 7, 5 or 10. Pick one. 2 plus 7, 9 plus 6, this is 15. 9 plus, okay. 2 plus 9 plus 4, we have 15. 6 plus 1 plus 8, we have 15. And we have 4 plus 3 plus 8, we also have 15. So I need to make sure I have 15 here and 15 here. What do I need to do to get to 15? 7 plus 3, 10, plus 5, that's 15. So let's say 5 on that side. 9 plus 1, 10, plus 5, 15. So it's going to be 5. So we have 5 is our missing number. All right. Good work. For those who are new, thank you for joining. For those who have been joining all this while, thank you so much for always coming along for the journey. And look forward to spending the next week with you. During the summer, we're going to have some programs for students that maybe feel like you did not get enough from your school year, especially with a lot of the changes going online. You may not have been able to finish your curriculum. So we're going to have a program to help you finish your curriculum and also to prepare you for the next subject that you're going to be going, your next math class for the next school year. And if you want to get more information on that, feel free to send us a message on info@mathis. You can go to our website, mathis.com, or call the number on the screen. And please send this message to your friends. Let them know that there's this avenue for them where they can ask questions. And last of all, subscribe, so that whenever we have videos out there, or if we post new videos, you get a notification. And also, whenever we're about to go online, you also get a notification. I want you to subscribe because sometimes I look at the topics that I see students struggling with, and I try to create a video for it just so that it sheds some more light on the different approaches that I believe are the best ways to go about it. And so I really thank you, and I wish you the best of the week. For those that are finishing school this week, and I hope you have had a good semester, regardless of all the things that happen at the end. And for those that are still going on, keep working hard and keep doing your best, and I'm sure you will do well and make yourself and your parents proud. So thank you for joining. See you next week. As usual, if you have any questions before we meet, you have ways to contact us. Feel free to do that, and we'll be glad to assist you. Thank you and have a wonderful day. Be blessed.